Hello students. Pumpkins have hit the supermarkets, right? So fall is coming. All right, we are going to begin dilations, and dilations are similarity transformations. So the cross product property is the first assignment. This is now the second in the module similarity. We will dilate. There will be a worksheet. I'll show you everything really quick. This will be quite a long video. Okay, I'll do two examples. It's graphing. What's going to take forever is me pausing this video so you can copy. Okay. And then the next video will be where we actually start the statement of proportionality and moving forward with similarity. Okay. Okay, we're now starting a new module of new curriculum. So your notes are an assignment. So you have the assignment, which is an entry, and you're also going to be submitting your notes, because how you just kind of wing the assignment is not going to happen. Okay, so you submit your notes and you submit the assignment. Okay. All right, here we go. Dilations are similarity transformations. Okay, so here's the notes. Right, so I'll pause it at some point. All right, that's page 1. Page 2 is now graph paper. The first example, or page 2, is an enlargement. I don't want to shadow it. Okay. If you're wondering what the points are, they're right here. Okay. So A is 1, 2, B is -2, -1, C is 2, -1. Okay, so that's where this is coming from. Okay, example 3, or I'm sorry, example 2, page 3, is a reduction. And, right, here's a quadrilateral plotted, right, the other was a triangle. Here are the points. Okay, and then the worksheet, so remember, you have to submit your notes, and they get graded. Okay, so this will be the worksheet that's the PDF. So if you notice, if you want to print the PDF, you can. It has little grids, but as you can see, you can kind of see the back page on the first page. So it's up to you. If you get graph paper and you construct this on the graph paper, that's fine too. It's just this is kind of nice because it really minimizes, or you can get 5 on one sheet. Okay. All right, so here we go. Let's dive in. Okay, dilations are similarity transformations. Dilations are isometric, isometry, right? Not. Okay. Isometric means they have equal dimensions. Now, how much of that we're going to dive into, we'll see, because we are on online learning. So I probably will on a challenge assignment, or just maybe I do one example and then there'll be an assignment of you just doing another. It's actually a lot of work. This video would end up being like 50 minutes long if I actually hit this part, but there'll be a separate video to prove this isometry. Okay, the dilations are isometric. Okay. Dilations change the size, but not the shape of the figure or the object. You know, dilations, it's like Puss in Boots, where the eyes dilate, cats, they dilate, or human eyeballs, well, actually all eyeballs, they dilate, right? Human eyeballs, they dilate when we're in the dark or we're in the sun. Okay, dilations in Euclidean space, which is geometry, which is the XYZ axes. Okay, we are geometry, right? This is kind of what we're going through. Us, okay, us, I am 2. We're dealing with the X and Y axes. Z, you will hit an I am 3. Okay, so like I said, you want to use this online learning to master your algebra and your geometry, because in I am 3, we build off of it. So you don't want to be struggling in I am 2 or I am 1 information, and then all of a sudden it's just piling on top of you, okay, because it's really rough. Okay, dilations require a center point, xy. Now, for this entire assignment and my examples, we're in the beginning, so we're only using the origin. Okay, I will upload a challenge assignment, but of course I have to write it and shoot it. It's when it's not the origin. So this is extra credit, okay? All right, and you have to have a scale factor. So dilations have a center point and a scale factor, and these are both highlighted yellow on the examples, okay? All right, what is K? K is an integer or a fraction decimal. So your K, or your scale factor, is 1/3, 2, 1/4, or 0.25, 5 or 1/2 or 0.5, 3, 1/5, 0.2, 3/4, 0.75. Okay, why did I not change the 1/3 into a decimal? You really want to be careful with that, because if you throw that in the calculator, oh, I have it. You know what? Let me just come to the side here. Okay, 1/3 as a fraction. If I hit enter, okay, you get 1/3, but if you hit SD to get it into the decimal, it's 0.333. It's a non-terminating 333. So I did not put 0.3 here because you're actually cutting off significant figures. So if you do that, because there will be an example on the worksheet, I think it's is it the third one? If you do that, yes, if you do that, you're going to go ahead and get decimals that you have to plot. Okay, some students are pretty accurate with it, but again, if it's a non-terminating, just leave it as a fraction, because then this calculator or the Desmos calculator can do it for you, okay? Okay, scale factor, K. K is your scale factor. Okay, it's a lowercase k, by the way, it's not capitalized. Okay, the value of K determines whether the dilation is an enlargement or a reduction. Okay, it's whited out. I accidentally added a C there, go figure. Okay, so the value of K determines whether the dilation is an enlargement or a reduction, meaning does it get larger or smaller? Okay, if K is greater than 1, K is greater than 1, right? That's what you should say when you see this. That's what you should read, right? It means that the dilation is an enlargement. It's getting larger, it's getting bigger, it's magnifying. Okay, if K is less than 1, K is less than 1, it's a reduction, it gets smaller or it shrinks. Okay, we multiply this K value, whatever the K values are, we multiply, that's the operation. Okay, to each of the given points, the X, Y, the ordered pair, okay? All right, there's your notes. We'll come back to this, but I realize all of this, it's not really making a whole lot of traction with you because you gotta do. Okay, this is an enlargement. Okay, so directions. Graph the dilated image of triangle ABC. Here's triangle ABC. Okay, what are the coordinates? A is 1, 2, B is -2, -1, C is 2, -1. Okay, so these points are given and it is plotted for you. Okay. Okay, so graph the dilated image of the triangle ABC using a scale factor of 2, it's highlighted, and 0, 0 as the center of dilation. And we'll get to that when I finish the problem. I'll show the center of dilation, and I'll show you the visual check of did you do it correctly, right? And that uses a ruler. Okay. All right, let us think. So we read this paragraph. What does it mean? Okay, my scale factor is 2. So it's an enlargement because 2 is greater than 1. So that means it's going to get bigger, right? Magnify, larger, enlargement, right? 2, greater than 1. Okay, so lots of words. What could it also say? Dilate about the origin, K equal 2. Dilate about the origin, K equal 2. All of this could also be that summarized, okay? Okay, you're gonna set this up and plot it. Remember, your notes for the now moving forward, these videos, your notes are also an assignment besides the assignment. So it's a double whammy. The CPP it wasn't, by the way, the cross product property it wasn't because it was review. Okay, so here we go. I have this set up so that it matches the worksheet. So notice you have JKL, J prime, K prime, L prime, MNOP, M prime, N prime, O prime, P prime, okay? So I have it set up the exact same way. It's just filled in, okay? So the given points, A, coordinate 1, 2, B, -2, -1, C, 2, -1. Okay, when they give us the scale factor of 2, that is what we multiply by. So multiply the K value to each of the ordered pairs, both X and Y. Because we're magnifying it. We're going to take this triangle and we're going to blow it up 2 times bigger. We're going to magnify it 2 times bigger. We're going to make it larger 2 times, by 2 times, okay? Okay, so what do? I have my points. I have them, right? And you multiply by 2, okay? So what is 1 times 2? And mind you, this arrow is that dilation transformation arrow, meaning this is the original triangle given. See, there's the original triangle. These are the coordinate points. That is called the pre-image, before. It's the image before I dilate. The little primes, A prime, B prime, C prime, okay, those points and that triangle, right, once you connect the dots, that is called the image. It's after the dilation. So before the dilation, after the dilation. Pre-image, image. Okay, so you multiply by 2. So 1 times 2 is 2. 2 times 2, 4. That's it, you guys. You multiply. -2 times 2, -4. -1 times 2, -2. 2 times 2, 4. -1 times 2, -2. So now you have the coordinates for the image. I have A prime location, I have the B prime location, I have the C prime location. So now all I have to do is go ahead and plot that on my graph. Okay, and then I'm going to use markers and I'm going to use a ruler, but it's pretty straightforward that way. Okay, A prime is 2, 4. So 2, 1, 2, 3, 4, right? Yeah, A prime. B prime is -4, -2, -4, -2. Yeah, that's -2. C prime is 4, -2. 4, whoops. -2. Okay. I just so don't want to mess up. You have no idea. I'm always like, wait. Okay, so my points are plotted. This is the pre-image and this is the image. A prime, B prime, C prime. That's it, okay? So now I need to connect. Oh, great. I got ruler. Okay, so the camera's kind of move a little bit because I'm gonna, let's see if I can do it. Oh, that was a little wavy. Oh, it's longer this way. All right, hold on, kiddos. I could have just followed the line, but... Well, that's terrible. Okay, let's not. Pretend it looks really good, you guys. Just be nice. Okay. All right, and now this one I really need to. So I'm going to kind of hold on, you guys. I'm going to zoom in. Okay, that's actually kind of hard too. Okay, so all I did was connect that line. Okay, so as you can see, here's my pre-image. Now we're going to color code, okay? So I'm going to use pink. Okay, so my pre-image, I will make it pink, right? So just kind of dot them. All right, so here is, right? Okay, so this is my pre-image. All right, and now I'm going to go ahead and my image. Are we good? Yeah, I can keep going. Okay. And so my image will be this blue. Okay. All right, so yes. Okay, so there's my pre-image in pink. There's my image in blue. That's it. Okay, you're done. This is it, right? 15 minutes, 15 and a half minutes into the video, you're done. However, what is your visual check? Okay, because I told you afterwards I would talk about the center of dilation. Okay, center of dilation means, remember, it says as 0, 0 as a center of dilation. And I told you all of them in this class, they're going to be 0, 0. Okay, what does that mean? It means that my center of dilation, my pre-image, and my image should all be collinear. So my center of dilation, I guess I should have given myself more space. My center of dilation, my pre-image, can you see? Oh, sorry, edit. Image, and my image. Oh my gosh, I keep wanting to make the A a G. So my center of dilation, my pre-image, and my image should all be collinear. What does that mean? They should all form a straight line. Now, if you want to do this, you may, but this part you're not required, but this is your visual check of did you do it right? And I really need straight lines. Okay, so what I mean is, so line up the image, see that 0, 0, the image, right? Okay, see A and see A prime. Hold on, I'm trying to hold it with my elbow. I've thought of using the hover cam, but yeah, see, it doesn't work. Okay, hold on, guys. Okay, so see how the image, A and A prime, are all collinear. They all sit on this ruler line. That means it is collinear. So just let me move the camera, okay? It's still hard, like, no, because the lines have to be perfect. Hold on. This can give you time to fix yours. Okay, so here is the line. Image, I'm sorry, center, 0, 0, origin, pre-image, image, they are collinear. Okay, so now do that for B. So here's my center, here's B, and here's B prime. Okay, so I'm gonna, hold on. This is the only downfall to this. Okay, so here is the center, pre-image, image, collinear. That is your visual check. If one of your points is not collinear, then you maybe accidentally multiplied incorrectly. Okay, so hold on. And so you just want to double check. Okay, and so image, I'm sorry, center, pre-image, image. And so there is my dilation. And so it shows, so center of dilation is, I could do it again, like I could prime it again and tell you, okay, go 3 times this A, and it's gonna be a little bigger. I could tell you go 4 times. And so it grows, it magnifies, it enlarges along these lines. Okay. Okay, there you go. I'm gonna make a second video of the reduction. No, let's just keep going. Okay, moving on. Let's go, because you guys can see it doesn't take too long. My graphing takes longer. Okay, we're now going to reduce. All right, directions. Graph the dilated image. It's a quadrilateral because it has 4 sides. Graph the dilated image of the quadrilateral MNOP, using a scale factor of 1/2 and 0, 0 as a center of dilation. So I highlighted the important parts. Okay, so let us think. K is 1/2 because it's a scale factor of 1/2. Scale factor is the letter K. 1/2, 1/2. Now, 1/2 is a nice decimal, and so that's why I did that. Because if I hit SD, 0.5. So this is up to you. If you want to multiply by 1/2 or 0.5 with your calculator, it is up to you. Okay, and on this one, I'll use the calculator just in case. I know we didn't do it on the other one because it was 2. Okay, your scale factor is a fraction. It is 1/2. It's a fraction less than 1. So K is less than 1, so it's a reduction. Now, if it's a reduction, that means that this is going to get smaller. It's going to start here, and it's going to shrink. It's going to shrink in. It's going to shrink in by 1/2, okay? So because the scale factor is less than 1, right, 1/2 or 0.5, either way, you know it's less than 1, it's going to be a reduction. So it's going to get smaller. It's going to shrink. Okay, so all of this, summarize, dilate the figure about the origin. K is 1/2 or K is 0.5. Okay, so here we go. What are the points? The given points, M is -6.2, N is 3.6, O is 8.1, P is -3, -4. That is the pre-image. That is before the dilation. The image, which is going to be after I multiply by my scale factor, right? The image is after you multiply by the dilated scale factor. And in this case, it's 1/2. And notice I have 1/2 here, but if you want to write 0.5, 0.5, 0.5, 0.5, or if you just want to write 0.5 at the top, that's fine if you know what you're doing. Okay, so that is after I have dilated. Remember, that's your transformation arrow. That's that you dilated, you transformed, and that's from the pre-image to the image. Okay, so that's what it should look like. I ended up putting a dot instead of a tick mark there. Go figure. See, we all make mistakes. Little minor errors. Okay, so let's multiply. Okay, this part's up to you. All right, so look, I know you guys can go 1/2, like what's 1/2 of -6, -3, but if you wanted to use the calculator, you can say, whoops, sorry. -6, can't even see, yeah, -6 times, and you can use 0.5, which is -3, or you could use -6 times, and you can use this fraction button. Well, not fifths, don't do that. 1/5, and you get -3. It's up to you. Okay, but since we're multiplying by 1/2 and you're very good at it, we usually keep it to those numbers. Okay, we don't, or 1/4. We don't really complicate you with decimals. Okay. All right. So -6 times 1/2. What's 1/2 of -6? -3. 2 times 1/2. Right. What's 2 times 1/2? 2 or times 0.5. Remember, we're multiplying 1. What's 3 times 1/2? Right, you should know how to do that. 1.5. 3 times 0.5 is 3/2, which is 1.5. Right. What's 1/2 of 6? 6 times 1/2 is 3. 8 times 1/2 is 4. 1 times 1/2 is 0.5, right? What's 1/2 of $1? 50 cents. Sorry, it's crooked. -3 times 1/2 is -1.5. -4 times 1/2 is -2. Now, you're very good at this. Okay, so after years and years of experience, students leave off the negative. So -4 times 1/2, students will sometimes write 2 there, and then their drawings messed up on a quiz or a test, and your only error was the negative. So remember, negative, negative, no negatives, no negatives, negative, 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 negative. Just take a second and just verify that. That's the biggest mistake here. Okay, there's always common errors. Like, it doesn't matter what high school, anywhere, the students just make the common errors. Okay, so now we're going to go ahead and plot that. So -3.1 is M prime. And notice, I know I'm graphing right because look, here's my center, 0, 0, my origin. Here's M and M prime, and they're all collinear. So I know I did it right. That's your visual check. N prime, 1.5, 3. 1, wait, 1? If that's 1, and that's 2, 1.5, 3. And prime, right? And notice, do your visual check. My center, my image, and my pre-image are collinear. So remember, this is my center. This is my pre-image, but I shrunk it because it's a reduction. So there's my image. Same thing. It shrunk because it's a reduction, right? Okay, go next. 4.5. This is 4. So then a half is like right here. And if it's a little off, just make your bubble bigger and make it fit. Okay, so there's my center is the origin. There's my, what letter am I on? O. There's my O prime. And there's my O, right? Okay. Afterwards, I'll put the lines together. I have to first connect it and do my best. Okay, P prime is -1/2, -2. So -1/2, -2, right here. And same thing, and you can kind of see whether or not you're doing it wrong or right. So notice, here's my image, pre-image, center of dilation, or my origin 0, 0. Okay, I need to connect these, so camera's gonna go weird. Okay, wait. I should just have it staring at one of the pumpkins, so at least you get something. But hopefully you're fixing your drawings, so you don't mind that it goes. I'm just connecting the primes, guys. Okay, I messed up that one. Okay, the phone was in the way. Okay, as you can tell. Okay, let's color code, right? So all I did was plot. All right, my pink is my pre-image, right? So pink, 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 pink. Oh, wait, sorry. Pink. All right, so that's the bigger one, right? My pre-image is the larger quadrilateral. Okay. And then my image, blue, blue, blue. And there you go. Okay, and like we already checked, they were collinear. All of them were collinear. So it does work, right? But I will draw the lines. You just know that the camera goes really bad. Okay. So, okay, I'm just gonna set it down and like you can watch, you can look at that right now. All right. Oh, that's better, right? Why didn't I do that earlier? Watch me mess up though, and I don't even, okay, if I mess up and I'm not carrying this camera, then there's no excuses. Like, what's my reason for messing this up? Okay, here we go. So there are my collinear. So this is your visual check. Collinear, right? Your center of dilation, your pre-image, and your image should all be collinear. It is so pretty. And if you really want to be super pretty, just, you can even color it in. Okay, worksheet. Okay, I won't write on this now, but we'll go over this kind of in class, but I'll give you guys, we'll probably wait another class day just in case students can get it printed. And then students will have questions off of this for sure, like the 1.5, and then this one here I solve with you, okay? All right, guys, thanks. Say bye to my little friends. It's my kids' toys from back in the day. Okay, bye, guys. Have a great day.